Okay, this is test number 2. Yesterday, I used this camera instead of YouTube's camera, so I could control the upload time. But it wouldn't let me record very long. Now, halfway through recording, it told me that my device ran out of space. So I'm hoping that that's been cleared up. I moved, I don't know, 12 gigs worth of data from the phone to the SD card, which was a lot more difficult than it needed to be. And then, so yeah, I cleaned up about 12 gigabytes of space on this phone. What's weird though is when I went through the data that was now on the SD card, there were a lot of things that I wasn't sure where they came from on the phone. For example, pictures that I know were old, pictures that I know I took months ago or even last year, but suddenly they're kind of like, suddenly they're there, and I could have sworn I'd not deleted pictures off my phone before, but I've, in Google Photos, in their Photos app, they have a feature called Free Up Space, which frees up all the space from photos that you've taken that have already been uploaded to the internet or uploaded to the cloud. So, for example, the other night I took some photos. They uploaded to Google Photos, then you hit the clear space or free up space option, and it removes all the photos that have already been backed up, leaving only the ones that haven't been backed up. See, and remember that statement. I'm going to come back in a second. So yeah, I was really surprised to find how many images, how many photos were still on my device when I could have sworn I deleted them multiple times. So I don't know where they were hiding or what they were doing, but they were in the images folder. So the thing I got to do now is go through Google Photos on my laptop and see if I can verify that those pictures are backed up. Some I don't care about, and I went ahead and deleted. I'm like, yeah, if it's backed up, great. If it's not, who cares? But some, like pictures of Rufus and whatnot, I'll be pissed if they get deleted. So anywho, that statement that I said, remember this. So this has been an issue of mine my entire life. And I think I've mentioned it before, if not on this camera, then on the other camera. I'm usually not the dumbest person in the room. Now, some of you might be thinking, no, dude, you're a freaking idiot. But I'm usually not the dumbest person in the room. And so there are a lot of things that I just assume everybody else understands or everybody else knows. So like that statement that I just said regarding photos backup. I almost didn't say the second half of that statement because to me it was a no-brainer. It was, a simple mathematical equation. If it wasn't this, then it's that. But I always find it surprising how often people don't get there on their own. They have to have things explained out to them. And it's a problem that I've had with people since I was a kid. Because to me, it's a logical conclusion. It is a reasonable statement. Or it is reasonable that you don't have to make that statement, which in itself is a statement, Because you don't have to explain it. And this happens every day. I mean, it even happens in writing. And it's one of the things I learned in college is if you're going to write a paper or something, you have to explain these things. But for me, it just seems kind of ridiculous. Why do I have to explain something that's so obvious? You know, for example, if you say something like, because of gravity, if he jumps off that roof, he is not going to fly. And then, because of gravity, if he jumps off that roof, he is not going to fly. But then sometimes you have to follow it up with people and say, because he's going to fall. And to me, that because he's going to fall is just kind of blatant in your face logic that it doesn't need to be explained. You don't have to say it. And yet I'm repeatedly confronted with people who don't understand that. So I wish I could think of more examples off the top of my head. But yeah, so in the past, 10 years or so, I've had to create a new habit, and that is over-explaining myself. Because I never know the person I'm talking to or expressing something to, I never know if they're the village idiot or not. So, what do we call it? Induction? No, not induction. Deduction. You can take a statement and deduce the intent or deduce what is not being said. And I remember learning that as a kid. Maybe in the 5th or 6th grade, maybe in early junior high. But I remember that, where the teacher was teaching us, if you read this sentence, when they say it's a clear sky out, and I'm using that as an example because we have a clear sky. When they say there's a clear, when the sentence in the story or the sentence anywhere says, the sky was clear, you don't have to explain that the sky was blue because everybody knows the sky is blue. Now, there are people who are going to say, well, what about nighttime when the sky is black? Or what about dusk when the sky might be orange and pink and green, or not green, but orange and pink and red? Well, that's going to be explained elsewhere in the story. If it's nighttime, chances are, it's going to say something, they're going to say something. Like they went out at 10 o'clock at night, the sky was clear. Okay, now you don't have to explain the sky was blue, nor do you have to explain the sky was black. The stars are there. These are reasonable deductions or reasonable inferences. I probably said that wrong. It's not a word I use every day. But to infer something, yeah. I think that's right. I don't know, there's two words out there that sound similar to each other, that mean similar things, but what they mean are completely different. If that makes any sense. And it's infer and something. Anywho, there's a little bit on Big Bang Theory about that. And that's all I'm picturing in my head right now is Sheldon Cooper correcting his friend. No, what you meant was to infer something is to XYZ, to what you meant is to ZYX. Kind of like the difference between venomous and poisonous. They're both similar. They both mean something is designed to make you ill or sick. The difference is it's venomous if it bites you or if it injects you, such as a wasp, a snake, something like that, a spider. It's poisonous if you touch it. So that would be a plant, a fungus, or something along those regards. So they both, result in the same thing, sickness or death. But the difference is how, who plays the active role. And then we get into active and passive roles. So the active role is what defines it. The snake is active, it bit you. The spider is active, it bit you. The wasp is active, it stung you. Therefore, they are venomous. You ate that mushroom. You touched that poison ivy. What else is poisonous? You swallowed those pills. Those are poisonous. So similar things. If you haven't guessed yet, I'm out earlier than normal. I woke up a little earlier this morning. Couldn't really sleep. And I was sitting there going, ho hum, ho hum. What am I going to do? So I decided to go ahead and get this walk going and get my metabolism burning. And I'll go back in, and when I'm done with this, and I'll have some breakfast. But yeah, there are a lot of statements out there like that. Like, I'll go back in and I'll have some breakfast. Where I said that, and the inference is, or the deduction is, that I have not had breakfast already. But sometimes I found you have to explain this to people, because they give you that blank stare that says they don't understand what you're talking about. And it's kind of like, I had this argument with my roommate years ago. We had a big argument. Where she, she said a bunch of statements. I can't remember the details of the argument. But she said a bunch of statements, and they all ran around the same subject. So, it was, there's a saying about it. Don't beat around the bush, just say it. Because she was talking around the subject. And then I deduced that she meant this. And she came back, as she always does, and she said, "That's not what I said." Okay, well, you didn't actually say that, no. But your statement of this, your statement of that, your statement of that leads me to believe that's what you're referring to. Because of deductive reasoning, because of inferring what she was trying to express without actually saying it. And it turns out later in the argument, I was absolutely correct. But she hates being wrong, or she hates being called out for things. And so she said, her argument was, that's not what I said. Well, and technically, verbatim, that is not what she said. But that's what she said. So, for example, and this was not the argument, but I think most of us can understand this. She would say things like, you don't do enough of the dishes around the house, and you don't keep that, and you don't sweep, and you don't mop, and you don't take out the garbage. What are you saying? And then I would come back and say, Are you trying to say that I don't do enough chores around the house? That's not what I'm saying. That kind of an argument. That's exactly what she said. Instead of saying you need to do more around the house, she said, here's a list of things you don't do around the house. And then it turned into another argument because I'm like, that's exactly what you just said. You just said I don't do enough around here. So, so yeah, like I said, I think knowing her as well as I do, it's just her way of not being wrong. She didn't want to be called out for it. She didn't want to say, this is actually what happened. She wanted to have control, and her way of keeping control is to say, that's not what I said. And I've been called out on it too before. You know, I'm talking to somebody. I rarely argue in the I'm angry, I want to argue sense. But I do like to have arguments in the academic, let's have a discussion with two opposing sides. Let's have a debate. And a synonym for debate is argument. That's why when you go to court, you make your argument, you make your case. And when people talk, they say, his argument is this, her argument is that. Has nothing to do with anger, has nothing to do with frustration. But most people take it that way because for some reason, either I'm surrounded by them or these people just exist everywhere. People want to take offense to everything. And that annoys me. It's like, hey, we're just having an argument here. There's no reason to get upset. God damn it. You just said we're having an argument. So you understand we're having an argument. Blah, 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 blah. No, we're having a discussion. We're having a debate. And then you got to go open the dictionary and show them that argument doesn't always mean a heated discussion filled with anger. It oftentimes means just having a debate. Because sometimes words have more than one definition. Welcome to English. And so you open up the dictionary, like right here, definition number 2, a debate. Okay. Yeah, but look at definition number 1. Okay, definition number 1 does not override or negate definition number 2. I am using the word and the meaning of definition number 2. So, had to do that a lot of times too. And each one of these things is something, I learned in college in a class called Language, Logic, and Persuasion. It's how to make a compelling argument, right there, a compelling argument. Not how to make a compelling debate, not how to make a compelling discussion, but how to make a compelling argument, how to present your side to where it's reasonable, rational, and logical. And I was so glad, when I got to college and I learned these things, that what I was doing, what I had always innately done, was not bad. Was not wrong, was not disrespectful. It was, I guess, to some people because they didn't understand. But what I was doing was perfectly acceptable in a broader world. I remember being a kid, arguing with my mom, or arguing with my grandma, or arguing with, aunts and uncles, or even other kids. And it was always, don't be a smartass, don't be a smartass, don't be a smartass. I'm like, I'm not being a smartass, I'm explaining it to you. Because they just didn't understand. They wanted to believe that there was only one definition for this, or they wanted to believe that what they thought was right. It's kind of like what's it called? Folklore wisdom or folkloric wisdom versus actual knowledge. So, for example, everybody knows when you're sick, eat chicken noodle soup. That's just, something that we have known as humans for a long, long time. Hell, I even read an article about it one time that said nobody knows why chicken and noodle soup works when you're sick. We just know that it does. Scientists haven't figured it out yet. Now, maybe scientists have since then. And then again, that's one of those things that I shouldn't have to explain, because I said I once read an article, so in the past, that scientists said we haven't figured it out yet. So up to that point that article was published. Leaving unsaid that a discovery may have been made since then, but I don't know about it. To me, that makes perfect sense. But to other people, they want to sit there and argue, well, you don't know if that discovery's been made since. And I'm like, yeah, exactly. I said that in the words that I chose. But, I said right here, not yet, and up to this point. These are things that you can infer. These are things that you can deduce from what was actually said. So, I remember being a kid, and, you have your conventional wisdom, your folklore wisdom, versus real knowledge. And I'd say something, your grandma or your mom or somebody would say something. It's one of those, I can't even think of the word that they're called. But those, I'm using the term folkloric wisdom. Those things that are just known, but nobody knows why. And they're passed around. They're passed down from generation to generation, such as chicken noodle soup is good for you when you're sick. But your grandma might say something like, "Oh, he's feeling ill. Get him some chicken noodle soup. It'll make him feel better." And you say, "Why?" And she says, "It just will. It'll make you feel better." That's folkloric wisdom. There's another name for it. I can't think of the word. And then maybe you come back in a couple of days and you say, well, this has happened to me. Come back in a couple of days and you open up an article or you open up a research paper or something, and you say, well, according to this, there's no scientific data, no scientific facts that show that chicken noodle soup is any better for you than anything else when you're sick. And then my grandma or my mom or anybody else would always say something, like, stop being a smartass. Not being a smartass. I'm just pointing out that your conventional wisdom is wrong or unfounded. Not necessarily wrong, because as the article stated, it was good for you. It's just nobody knew why. So, you say something like that, and, but you do that over and over and over again. My grandma, and I didn't know it as a kid, but I know it now as an adult, and she died 12 years ago. But, she wasn't the most educated person. And if somebody had told me that when I was 20, hey, go easy on your grandma. Her generation didn't get to always finish high school. Her generation didn't go to college. I would have gone a lot easier on her. And that's one of those things I've had to come to the conclusion with my mom, because she went to high school. She graduated high school, as far as I know. But that was it. Aside from once, about when I was 7 or 8, maybe 10, somewhere in there, she took a couple of college courses, night school courses. At least that's what she said she was doing. I've also learned that, you know, everybody lies. For all I know, that was her, you know, Netflix and chill. For all I know, she was going out on dates and telling people that she was taking night school courses. I don't know. What I know is that she did it for a few months, so roughly a semester. She was gone like 2 nights a week. And then out of the blue, she stopped going, and I asked her why. I said, well, why don't you want to go to school anymore? And she said, oh, my company stopped paying for it. So I was always under the assumption that she was taking night school courses at the local community college. But as I'm thinking about it right now, maybe she wasn't. Maybe she was taking some sort of professional training that her company provided, and the training was over. Or maybe the company came out and said, hey, we want everybody who works for us to have these skills, so we put together a certificate program or a additional learning program consisting of, you know, 4 classes over the course of the next semester or 2 semesters or whatever. I don't know. All I know is what my mother told me, and that was she was taking night classes because she wanted to get her degree so that she could advance in her career. But knowing my mom as I do, she has a very, very loose interpretation of reality. Not saying this, hey puppy, not saying, you know, she's out of her mind or, you know, in need of medication or anything, but she always gives you the version of reality that she likes. She doesn't just give you reality, or the version of reality that makes her feel more comfortable. And sadly, that's something that, you know, I picked up over the years. I don't like doing it. I like being real. I like being honest. I like being straightforward. Back in the 80s, we might have called it raw, like Eddie Murphy raw. Yeah, I'm not going to pull any punches. I'm going to lay it out flat for you. Here it is. And that's how I prefer to be. Let each individual make their own interpretation. You just provide the facts. Now, I've also learned over the years that if you just provide the facts, pardon me, if you just provide the facts, a lot of people are going to come to the wrong interpretation or the wrong conclusion. Yeah. So yeah, like for example, you might say, you know, sugar has been proven as a leading cause of obesity in North America, which is true. And if you start looking at food labels, all of our food has sugar in it. Our bread has sugar in it. Our sodas, our Kool-Aid has sugar in it. Our fruit juices have added sugar. Gatorade, sugar. Some of these water things that, you know, I don't know any particular brands that have it off the top of my head, but some of these water that you know, companies put out there is better than regular water because it's got XYZ in it or whatever, but it still looks and tastes just like water. Sometimes they have sugar in it. Almost all processed foods have some kind of sugar in it. So, you know, we do have a sugar, and when I say sugar, I don't mean just raw sugar. I mean, I'm talking about sugar. I'm talking about your sugar substitutes. I'm talking about your honeys. I'm talking about your high fructose corn syrup, your fructose corn syrup, your corn syrup. Everything has sugar in it. It's amazing. Go look at your bread. Go look at your cereal. Go look at your Gatorade. Your Gatorade might have more sugar in it than a soda does. Depending on, you know, which Gatorade and flavor you get and which soda you get. But you might say something like, you know, sugar is a leading cause of obesity in the United States. And you just might put that out there. There you go. Well, somebody's going to pick it up and say, oh, well, I need to cut down my sugar. Yes, that's what our intent was. And some people are going to say, oh, well, I need to cut down on I don't know, I'm trying to think of one that I've read or heard of, and I can't, but let's just say somebody else might come back and say, well, I need to cut down on fruits. Well, why do you need to cut down on fruits? Because fruits have sugar in them. And if I'm already drinking too much soda and Gatorade and eating too much processed bread that has sugar in it, then I can't afford to eat any fruits because it has sugar in it. Like, no, wrong conclusion. So that's my point is, I've learned over the years that if you put the information out there, people sometimes draw the wrong conclusion. Problem is, I don't like drawing conclusions for other people. Mainly because then people want to sit there and argue back and forth with you, and which I love the discussion. I do. I really do. I love having the discussion. 9 times out of 10, in my experience, the people that want to argue with you are the people that don't know what they're talking about. So, you might get a Jenny McCarthy out there telling you that when you say you need to get your kids vaccinated, she's going to be the one running out there saying vaccines cause autism. How can you tell people they need to get their kids vaccinated? You're telling them to stunt their kids, blah, blah, blah. And it's like, no. There's no scientific proof out there that shows vaccines make kids autistic or cause autism. There was not one drop of it. The only scientific, and I say scientific with the quotes around it, air quotes, the only pseudoscientific information out there that supports that is exactly that. It's pseudoscientific. But it's those people, the ones who are adamant that they're right, even though they're wrong, that really want to argue with you and push you. And it's not that they want to have the discussion, it's that they want to be right. And don't get me wrong, I want to be right too, but I also want to have the discussion, because it's in that discussion, which is an exchange of ideas, where you might be proven wrong. And I've been proven wrong many times. Either I have incomplete or inconclusive data, or what's the other thing I was going to say other than incomplete and inconclusive? Wrong data, which I guess could be incomplete and inconclusive. But yeah, there's things out there like that where it's like, I've been called out before, and they're like, well, here, you're wrong. Here's the data you're providing. Here's the actual data. And I'm like, oh, okay, yeah, you're right. Absolutely. So I have to adjust how I think and understand certain things. And that's exactly how we as people should be. We should be willing, we should be open to change. Now, there's nothing wrong with believing what you believe, but when you're shown proof, when you're shown evidence, you should adjust what you believe. Even if it's going so far as to saying, well, I believe ABC, but I've been shown that C is correct or incorrect. So I still believe ABC under the caveat that C might not be true or might not be factual or whatever. In which case, when it is proven in, unfactual, or proven with empirical data that, then I will change my belief or my thoughts on this particular subject. And that is how we should operate. Now, somebody's invariably going to say, but, data doesn't always prove everything right. We're constantly reproving things. Yes, we are. And that's called the scientific method, and it's fantastic. It's wonderful. You do a test, you get a result. You repeat the test, you get the same result. You repeat the test, you get the same result. Over and over and over again. And that's how they determine, hey, here's something that's true. Here's something that's factual. Oddly, I can't find a decent one right now. I'm looking for a pine cone or a stick or something. Okay, here's a stick. So, here's a stick. You drop it, it falls. You drop it, it falls. You drop it, it falls. Anywhere on the earth you go, you drop it, it falls. Hey, we proved gravity. Gravity pulls something down towards the earth. And then, oh, no, that's a really bad example. I was trying to think of something that was overturned. Gravity has not been overturned. Our understanding of gravity has changed. Back in the 17th century, we understood what gravity did, but we said it pulls it towards the earth, just like I was doing. But then we now understand that everything has a modicum of gravity to it. The larger the mass, the more gravity, such as planets have more gravity than moons typically do. Stars have more gravity than planets typically do. But then you do a collective and you say the solar system has more gravity than that one planet over there, or that one, maybe not that one star. But the galaxy has more gravity than this galaxy, blah, blah, blah. We changed our understanding. It's not about, gravity isn't something just the earth produces. Gravity is something everything produces. It's just that our understanding of mass and gravity has changed over the years. But I was trying to think of something else, because things are overturned all the time. Conventional wisdom, something that was accepted as a scientific fact back in the early 20th century has been overridden and proven wrong with new evidence, new research. And that happens all the time, and it's fantastic. It's wonderful. But yes, that does mean that certain things out there are subject to change. And then some people will come back to whatever argument you bring up, whatever scientific proof you bring up. They're going to come back and they're going to say, well, other things have been proven wrong. How are you going to prove yours? How do we know yours is right? How do we know yours isn't just wrong? It hasn't been proven wrong yet. In which case, those are the kind of people I don't want to argue with, because they don't understand the process. Yes, this could be proven wrong. And they don't understand the difference between theory and fact. There are scientific theories, which are things that cannot be proven 100%, but they can be proven, as being reliably this way, such as the theory of evolution. It is a scientific theory. It states that all existing evidence leads you to this conclusion. That life adapts over time to its environment. But the only way to actually prove it, because evolution happens so incredibly slowly, we're not talking over the course of generations, we're talking over the course of thousands of generations. Unless, we're talking about bacteria. Now you can watch bacteria and viruses evolve, over the course of, days or hours. But then somebody's going to come back and say, well, those are single cell life forms. Those aren't as complex as human beings and bears and, rabbits and stuff. And if we evolved, how come there aren't, fish people out there right now, coming out of the water right now? Well, it's because they don't understand how evolution works. And then you have to go back and have like a basic, very simple kindergarten grade conversation about how evolution works. But the only way to prove evolution works on a grand scale is to actually witness it. Now, like I said, evolution happens over the course of thousands of generations. This bird's beak doesn't get bigger or shorter or thicker or weaker based on its parents weren't able to eat. It's based on thousands of generations of trying to crack through a new kind of nut, or trying to tear apart a certain kind of flesh, or something like that. It takes place over, like I said, thousands of generations. We're talking thousands of years, even longer. But people want to have the inane conversation and say, oh, well, that doesn't apply. And because, it may be proven wrong. because it's only a theory. Well, the theory says that by all existing evidence, this is what we can come to. This is the conclusion that we can logically and reasonably come to. This is our theory. Now, the only way, like I said, to really observe it is to observe it in real time. To say, okay, well, we watched over the course of thousands of generations as this, what do you call it? Oh, I need to go this way. I came out the back door. Thousands of generations as this evolution occurred. And you can't do it. That's why it's a theory. Now, like I said, we can do it with bacteria. We can do it with some simpler life forms that reproduce much more quickly. But then somebody's going to say, again, that it doesn't apply because, you know, you're comparing us to bacteria. Or you're... So, roommate's got Charlie out. So yeah, while there's facts such as gravity, we can prove gravity, or scientific facts. And things like that. Sorry. So they're, scientific facts, things that can be proven beyond a reasonable doubt. 1 + 1 = 2. Scientific fact. It happens. It happens that way in Florida. Happens that way in Alaska. Happens that way in Taiwan. Happens that way in England. Happens that way in South Africa. Happens that way on the moon, on Jupiter, across the galaxy. 1 + 1 will always equal 2, using conventional math. Because somebody's going to pipe in and go, well, in binary, 1 + 1 = 0, carry the 1. Yes, but we're not talking about binary. We're talking about conventional math. 1 + 1 will always equal 2. 2 + 2 will always equal 4. So, those are facts. Those are things that are irrefutable. You cannot contest them because it's true. Now, there are so few scientific facts because there are so few things that are proven, I don't want to say infallible, but proven that can be reproven over and over again, and that scientists know will be proven 600 years from now, or 6,000 years from now. That's why there are a lot of theories, and that's why the dumber people not understanding that a theory is just a scientific theory is different than a philosophical theory. Philosophical theory, your theory is pretty much a thesis. It's saying, here's what I think, and then you go and prove it. Basic, paper writing 101, basic scientific research 101, basic everything 101. You put your theory, your belief up there at the front. You say, here's what we believe. And then you say, here's how we're going to test it. Here's how we tested it. Here's the results that we got. Here's how it either proved or disproved our theory. Here's how we're adjusting our theory. Done. And then you have a new theory. And then what do? That's right. You go back and test it and see if you get the same results. That's how it works. That's how it's supposed to work. That's how it works in the 6th grade when you're writing a paper on George Washington. And that's how it works, in the DARPA, in the biggest research labs, the most advanced research labs in the world. So, and that gets us back to possibilities and probabilities. It's another way of saying it. It's just a simpler, easier way of saying it. The possibility is that my theory is going to be correct. There's a possibility my theory is also going to be incorrect, because there's always out of 100% possibility my theory being correct is 60%. That means 40% it might not be correct. You give what's the probability your theory is correct? Well, the probability my theory is correct is 30%. But we won't know until we test it. So there's a 70% probability your theory is not going to be correct. Somebody might say, the sun rises in the east. And yes, it does. Is that a scientific fact? For the most part, yes, it is. However, is it possible? Is there any kind of possibility out there? That's what you're asking. Is there any possibility out there that one day the sun will rise in the west? Yes. Now that possibility is so infinitesimally small that we don't have to worry about it. But the possibility is out there that it will happen. The Earth's core could decide to rotate the other direction, thus slowing the Earth and turning it in a different direction. We could get hit by a massive gravitational pull from a body moving through our solar system that whips us around the other way. Kind of like if you take a pool ball and you spin it, but then you hit it with the cue and you hit it the other way and it spins the other way. We could get hit with a giant meteor, a meteor the size of our moon, which turns around and forces the Earth to spin the other direction. All these things are life-ending, but is it a possibility? Yes. Now that possibility, again, is so infinitesimally small, it's nothing we have to actually worry about, but it is a possibility. And, I thought it had stopped recording. So yeah, what's another one that I'm thinking of? Yeah, if somebody shoots a ballistic missile at me and it hits, it hits right here in front of me, am I automatically going to die? Not necessarily. That missile could always not explode. Now there may be a concussion blast that knocks me off my feet from it, from the force of the missile hitting the force of hitting the ground, and that force has to be expelled, and it forces me, 20 or 30 feet back. But will it necessarily kill me? No, or not no, but not necessarily. There's always the probability that missile does not explode. And we heard about that a lot in the 90s and early 2000s, where we were launching missiles at various peoples. And the missiles weren't exploding, so they're like, each one of these missiles costs $10 million, and it's a $10 million dud. There was always that possibility. Now, the scientists, the engineers, the physicists, whatever, are always out there trying to figure out a way to reduce the probability that it doesn't explode. But that probability always exists. Another one I like to use. Is there a possibility that a UFO will land right there in this open space right here? There is a possibility, but it is so infinitesimally small, there is little to no probability. So that, it always gets back to, is it possible? Yes. Is it probable? No. But the problem is people want to be certain in their assumptions, so very few people want to work in the gray areas. They want everything to be black and white. They want everything to be yes or no, or you go to a court of law and say, the DA asks you, is it possible that you're wrong about this? You say, well, there's every reason in every possibility in the world that I'm wrong. However, knowing what I know, knowing the facts, having the facts in front of me, the probability of me being wrong is very, very small. Oh, but you're saying it's possible. Well, yes, it's possible. It's also possible that a 30-foot giant will reach in here, scoop up the jury pool, and swallow everybody one by one. But it's not probable. But everybody wants to be certain, and especially, I don't want to say less educated people, but less educated people want to be certain about everything. And so they will fight you tooth and nail on little minute details when those, because they just want to be right. They want you to be black and white when you can't be black and white. You have to live in a world of gray. We could actually say that pure black and pure white are so improbable as to be nearly impossible, that everything is a shade of gray. Everything. Even that pure white piece of paper that you're looking, that you put in the printer or you get out of the cabinet or whatever, may not, be pure white. It may be white with a 0.0000001% defect, which makes it not pure white. But, somebody's going to tell you, hey, it's white. Well, for all intents and purposes, it is. In common vernacular, it is. But in reality, it may not be. When you tell people there are, 80 million color schemes out there, I don't even know what we're up to these days. I remember 8-bit. I remember 256. I remember when something came up, we have 16 million colors. And I'm like, there are 16 million colors? They're like, oh yeah, there totally is. You can't sit there and say, well, I have a monitor that gives me 4K and, 100 million colors, and then sit there and argue that this is pure white and this is pure black, because, let's face it, it's not. This black shirt that I'm wearing, for all intents and purposes, it's black. But in my eyes, it's more of a very dark charcoal gray. My pants, or here's a perfect example. My pants versus the shirt. They're both black, but my pants are a blacker black, which means my shirt is not a real black, which means it is on the grayscale. Yeah, I mean, look at the sky. We say the sky is blue, but look at that blue versus that blue versus that blue versus that blue. The sky is all shades of blue, or all kinds of blue. But in common vernacular, we'll say the sky is blue. But in reality, the sky is, 100 different shades of blue at any time of day. It takes into facts of the position of the sun, the angle of the earth, the amount of atmosphere, the amount of water vapor in the atmosphere. I guess that would be the amount of atmosphere, but then we break it down into all the different gases that are in our atmosphere, blah, blah, blah. So, I don't know. I've been talking for about an hour. I'm ready to have some breakfast. I hope I made some kind of a point. Point is, some people want to be right all the time. Some people want to be correct all the time. But you're not always right when you're correct. Did I say that right? Sorry, I'm just going in the bottom door here, since that's the way I came out. Some people just want to be right, even when they're wrong. And I don't like arguing with those people. I got into an argument years ago, or about a year and a half, 2 years ago, with a guy who swore up and down fluoride was destroying our brains, making us a compliant population. And that was a big conspiracy theory. And, in the United States here, I'm not sure about elsewhere in the world, but we put fluoride in the water because it's healthy for your teeth. It helps keep your teeth stronger, which is perfectly fine. And then a year or two ago, science came out and said there was a study that proved that fluoride could have a reaction on your brain. And all these conspiracy theorists came out and said, see, we told you, we told you, we told you. So I had one of these guys do that, and I said, hey, look, here's the difference. We're putting in 1 parts per million, or 1/4 of a part per million of fluoride in the water. That's what we're doing. This study, the one that you said can affect the brain, they're talking about, a 1-for-1 or even an overdose of fluoride over a long period of time can affect your brain, not the 1 parts per million that's in the water. And I'm making these numbers up because I don't remember the actual numbers in the articles and the proof. And I produced scientific studies. I produced CDC studies. I produced university studies. And this guy he would not have it. He just said, oh yeah, you see, they just proved that, we were right all the time, that our conspiracy theory wasn't a conspiracy. They really are trying to control our brains with fluoride. And it's like, no, that's not what's happening. They're not trying to control your brain with fluoride. But like anything in the world, if you change your diet, if you change where you live, if you start eating a different kind of food, if you drink too much or drink too less, or have too much salt, or have too much sugar, or have too much whatever, or all they're saying is that, like anything else in the world, if you have too much over too long of a period of time, it can physiologically alter you. If you have too much protein, it can change how your body works. If you have too much fiber, it can change how your body works. If you have too much sugar, it can change your brain chemistry. If you have too much acid, it can change your brain chemistry. I mean, these are, just known things, and all they're saying is this applies to fluoride as well. Surprisingly, these people who are upset about fluoride in the water are not upset about the amount of sugar in all of our foods. They just want to go after fluoride. So, anywho, I'm home. I babbled enough. I was able to record 55 minutes so far, which was kind of cool. And I'll upload it tonight. All right, so I'm going to let me go.